Hello. So today I'm going to talk about. Okay, let's just choose the right pen here. So I'm going to talk about combinatorics. Okay, so combinatorics is a fancy word for counting. Right, and typically how do you count? So you have, let's say, these are apples. So let's say there are 3 apples, and even a child actually could count these apples. He will say this is apple 1, this is apple 2, and this is apple 3. So this is counting by actually looking at the object and counting. So and typically it's taught to young kids by counting on their fingers. Now it in business analytics, combinatorics is very important. Typically what I find is that these topics are generally taught in undergraduate level or in the school, but sometimes they are not understood well. For whatever reason, I think we can do a good job of refreshing these concepts, and I hope this small video will help you understand all the different ways, important ways in which several problems can be counted, right? So we will first talk about let's begin with an example. So let's look at 3 places. So these places are, let's say, these are places in Singapore. So first place is Bishan, second place, let's say, is Kovan, and third place, let's say, this is Sengkang. All right, now to go from Bishan to Kovan, one may take these 3 routes. So this is route 1, route 2, route 3. To go from Kovan to Sengkang, one can take either expressway 1 or expressway 2. Now the question here in this example that we are discussing is that we want to go from Bishan to Sengkang, and we want to know how many ways are there to go from Bishan to Sengkang. Now this has 2 sequences. So first you have to choose one among R1. So you have to choose basically one route here, and you have to choose another route here. So there are 2 steps. This is step 1 and this is step 2. So so let's just count it using the primary school counting, which is to list down every possible way. So let's look at that. So you can choose route 1, then you can choose expressway 1, or you could go choose route 1, but you choose actually expressway 2. So these are 2 ways. Or you could have route 2, expressway 1, you could have route 2 or expressway 2, or you could choose route 3, expressway 1, or route 3, expressway 2. So this is the usual method, and I guess it's easy to see that actually we could have counted without writing down all the possible routes. That is, number of ways to do step 1 is 3. Number of ways to do step 2 is 2. So the total number of ways, I will write it in this fancy pound sign. Total number of ways is 3 times 2, which is 6. So this is called a rule of multiplication. Right, so let's try to generalize this a little bit. So we generalize this as follows. So instead of having two steps like we had before, let's say there are small r steps, and like before, first step can be done in n1 ways. I will not write like this, I will write n, and in the bottom I will write 1. The second step can be written as n 2 ways, and likewise the rth step can be done in nr ways. So the total number of ways in which we can do these r steps. So think of there being a big task, and each task has to be done with r steps or subtasks. So the number of ways in which the task can be done is very simple as before. It is n1 times n2 times n3 and so on. You keep multiplying times nr. So this is the general way in which you talk about rule of multiplication. Let's change a color, let's make it a little prettier. So let's choose this. So now let's talk about permutation. So again, as before, we will look at an example. Let's assume that you have 4 toys. You have a Barbie doll, you have a teddy bear, you have a Captain America, and you have a G.I. Joe. Now your task is that you have to arrange these 4 objects in a row. So basically you have to arrange them. Okay, so basically you have to arrange them, let's say in the order of your preference, which is the object that you like most. Now and now you would like to count what are all the ways in which a child could like these. So there could be a child, for example, who likes Barbie doll first, then likes teddy bear, then likes Captain America, then likes G.I. Joe. This is one way. There could be another child who likes G.I. Joe first, likes Captain America next, likes teddy bear, likes Barbie doll. So now what we are interested is, like, basically we want to arrange them in all possible ways, right? So let's just clear this. So again, just to so you could, for instance, enumerate all possible ways by, like, this could be one way, or you can look at, sorry, so this is already done. So you can look at G.I. Joe, CA, or you could always count all of this way. But now that we have learned, let's choose some dark color. Yeah, so now that we have learned rule of multiplication, we can do better. So how do we count this? So we know that the first toy, the most preferred toy, can be chosen in 4 ways. There are 4 ways I can choose the most preferred toy. Then the second step, I can choose the second favorite toy, but already the first preferred toy is gone. So the second preferred choice can be only done in 3 ways. And then the third toy, that means first and second has already been chosen. The third toy can be done in second way. and finally the last step is fixed. You have to choose whatever is left. So this is the number of ways in which you can arrange basically 4 toys, which is 4 into 3 into 2 into 1, which is 4 is a 12, 24 ways. Now instead of 4, if there were n toys, and I was supposed to ask you how many ways there are, then the answer is n into n minus 1 into n minus 2 and so on till you reach 1, and there is a shorthand for that, that is called n factorial. So this is very, very important. This is a exclamation mark. I might have gotten the spelling wrong, pardon me. So this is basically called as n factorial. So let me write the exclamation mark once again. So it's a dash followed by a dot. So this is basically technically called NPN. So basically there are n toys and I want to arrange n of them in the order of preferences, and that we just showed is n factorial. Now suppose you go to a toy shop and then you see these n toys, but your parents have already told that you have to choose only R of them. And then now given that, the question that comes next is like, what is the preference? Basically you cannot choose all of them, you have to choose only R of them. So how many ways is it possible that I can do that? So basically, as before, there are n ways to choose the first object, n minus 1 to choose the second object, right? So there should be totally R steps. So this is the first step, this is the second step, and then finally for the rth step it will be n minus R plus 1. This is the rth step. So this is called NPR. So let's start with a new page. So what we discussed is that we looked at basically NPR, which is n into n minus 1, so on. Now what you can do is that we can make a simple expression out of this as follows. So basically, if you notice, what is the difference between n factorial and this? So n factorial had other terms. It had terms like n minus r. So this thing into n minus r into, let me put these brackets. I'm sorry, let's just zoom out a little bit. Okay, something happened. Okay, so basically n factorial and NPR is differing by just these. So it has these missing terms, right? So you have this, then n minus r minus 1, and then all the way up to 2, and then finally 1. So these are all the missing terms. So essentially, basically, if you take NPR and multiply it with n minus r factorial, you will get n factorial. So therefore a simple and elegant way to write NPR is n factorial divided by n minus r factorial. So let's look at a simple concrete example as to what is an application of this. So let's take the example of a toy store again. So you are a company which manufactures n toys, and then there is a toy exhibition coming up, and you have to showcase r of them. So obviously the first showcase is most important, and so this is the first showcase, then you have the second showcase, then you have third, and finally you have the rth showcase. Now an application is, what is the question that can be asked is, how many ways can you conduct the showcase? And the answer immediately is NPR. Okay, so that is one example. Let's look at another example. So let's say from the class of BBA students, I need to choose one student rep, second one is events manager, and third one is, let's say finance secretary. So let's say the BBA class is of strength 50, so n is equal to 50. My question is, how many ways can I choose this 3-member group? And clearly there are so if I choose, let's say, student Aaron as student rep, and I choose Cynthia as events manager, and let's say I choose Ron as finance secretary, this is a different way than if I choose this guy as an event manager and Cynthia as a student rep, or Ron as a finance secretary. So these are two different ways. So the answer to this is again 50p3, and as before we can write this as 50 factorial minus 50 minus 3 factorial, which is 50 into 49 into 48.